Today we discuss about the feedback topologies. So before that, what is feedback amplifier? Feedback amplifier. We already discussed about feedback. Amplifier. So now feedback amplifier generally consists of two parts. There are amplifier and the feedback circuit. Like we know, the symbol of amplifier. This is the symbol of amplifier. Input and output, Vi input and V0 output, V0 output. So with this, there is a feedback circuit which is consist with resistor that is called beta, is the gain of this circuit, input of this circuit, feedback circuit V0, and output of this circuit Vf. For the whole circuit, the input Vs, voltage source, source voltage. So whole thing is called feedback amplifier. This is the basic amplifier with this feedback circuit, and whole things is called feedback amplifier. So in this case, you see here the plus minus. So we can write the gain of this circuit, feedback circuit, that is, we can write Vf is equal to beta V0. That means beta is equal to Vf by V0, because Vf is the output of the feedback circuit and V0 is the input of the feedback circuit. So if you see here, there is a Vi. If it is V plus Vf, or Vi is equal to Vs minus Vf, we can write Vs plus Vf is equal to beta V0, and here Vs minus beta V0. So here you see Vi means the gain of this circuit, the amplifier circuit. A is equal to output by input. So output is equal to V0 is equal to AVI. Okay. So we can write Vs minus beta V naught is equal to, sorry, uh, this is, you can write A is equal to V naught, because Vi is equal to V naught by A is multiplied with this, so V naught is equal to this. So here A Vs minus A beta V naught is equal to V naught. So A Vs is equal to V naught 1 plus A beta. So we can write V naught by Vs is equal to A by 1 plus A beta. Whereas in this case V naught by Vs is equal to A by 1 minus A beta. So you see here the gain we know A, and with the feedback V naught means output and Vs is input. That means this is called AF, feedback of the gain of the feedback amplifier whole circuit. AF is equal to V naught by Vs is equal to A by 1 minus A into beta, and in this case 1 plus A into beta. So here it is called, the feedback is amplify the positive feedback because we add here, so it is called positive feedback. And here you see due to the negative, so it is called negative feedback. We subtract it, so we are interested right now about the negative feedback. We also discuss about positive feedback further when we discuss about the oscillator, because some certain condition we can design the oscillator circuit. Oscillator circuit just opposite of the rectifier circuit, which is AC to DC or oscillator DC to AC. Whereas we are interesting about the negative feedback. So negative feedback, basically here you see negative feedback amplifier is an electronic amplifier that subtracts a fraction of its output from its input, so that negative feedback opposes the original signal. The applied negative feedback can improve its performance and reduce sensitivity to parameter variation due to manufacturing or environment. So we can see uh, see the feedback topologies, the block diagram of the feedback amplifier. Before that, we see block diagram of feedback amplifier. Block diagram of feedback amplifier. signal source, then mixer network, then basic amplifier with gain A, then sampling, feedback network with beta gain, input Vs, source voltage, output with load, output V naught, input of the feedback network, V output, and output of the feedback network, Vf, and this is Vi, which is Vs plus minus Vf. So this is the block diagram of the feedback amplifier. So you see previous one, this is plus minus, this one is nothing but a mixer, and this point sampling, that means if it is voltage or current, it can divide by two branch, and here mixing. So due to that, this network is called mixer network, and here sampling network, which is divide or sampling the output in terms of current or voltage. So depending on this, we can classify the four basic feedback. Number one, voltage sampling. Voltage sampling, series mixing, which is called also series shunt, topology. Series shunt, series mixing, voltage sampling means shunt sampling. Voltage, when we measure the voltage or divide the voltage, we can sampling, then it is shunt. And when we see the current, then we see in series. You see number 2, current, sampling, shunt, mixing. So it is called also shunt, series, topology. Number 3, current, sampling, series, series mixing. So it is also called series series topology. Number 4, voltage sampling, shunt, mixing. It is called shunt topology. So these 4 basic feedback topologies. What is voltage sampling? You just understand that why sampling. Voltage sampling means it is output, it is sample. Series mixing, in series it is mixing, or sometimes it is called series shunt. Series shunt, series in mixing, first series then shunt for voltage, then current sampling, shunt mixing, shunt and series, current sampling, series mixing, series and series, voltage sampling, shunt mixing, shunt topology. So now we see the block diagram of different feedback topologies. Block diagram of different feedback topologies. So this is the block diagram of different feedback topologies. So first you see this is a series shunt. Series shunt. Series shunt means series shunt voltage sampling and series mixing. So you see here input voltage source Vs with input resistance Rs. It is connected with basic voltage amplifier where the gain is terms of AV, voltage output by voltage input. That means we use here voltage amplifier. বাবা বলো ক্লাস নিচ্ছি যাও voltage amplifier we use here, and feedback network, the beta is the gain VF by V naught. হ্যাঁ বলো excuse me. Okay, so you see we use here voltage amplifier. That means the input is voltage and output also voltage. So basic voltage amplifier here. So here the series sorry, shunt sampling, series mixing. You see V naught in series. This is plus, this is minus, which is connect with this. That means Vs minus Vf in series. That means the Vi is nothing but a Vs minus Vf. Whereas you see in output there is a uh, shunt sampling. Shunt means you see voltage in parallelly connected voltage source. The positive terminal connect with here, negative terminal connect here, and the output current I naught. So this is the series shunt topology. Next, shunt series. That means series sampling, shunt mixing. So shunt mixing, you see, shunt mixing. So that means in this case, we need to use basic current amplifier. The output current and input current. Output current by input current is the gain AI. So here you see the mixer is shunt mixing. So we get the current is, the source resistance is parallel. So is here, where I is indicate towards the basic amplifier, and if indicates towards the feedback amplifier. So II is nothing but a is minus if. So here also negative. So this is your shunt series, and series, that means series sampling and series currents sampling and series mixing. So series mixing, you see here VF, and here current sampling also in series. So in this case we use or here apply basic transconductance amplifier, where the output is I naught, input is I naught and Vi. So we know Vi is equal to Vs minus Vf, output is Vf. So beta is equal to Vf by I naught. Similarly, in case of shunt, that means voltage mixing and shunt voltage sampling, shunt mixing. So voltage sampling, shunt mixing, you see both are in parallel. This point in input and this point in input. For this, here use basic trans resistance amplifier, where the output is V naught and input is I. So here I is nothing but a is minus if, because if is the opposite direction. So feedback network gain beta is nothing but a output by input. Output is I, which is if, and input is V, which is V naught. So if by V naught. So these four topologies, this is the block diagram of the four topologies. Now we see the how to it is work, or the why we use, and which one is better for, or the advantages, which one better. That means in terms of input impedance, in terms of gain, in terms of output impedance, in terms of noise. So which one better we see. So one by one we see, we find out the gain for each topologies, and find out the input impedance, and find out the output impedance. So first we see current sampling. First we see current sampling, shunt mixing. That means shunt series topology. Shunt series topology. This is the equivalent circuit diagram. So here you see for the basic amplifier, this is the input resistance Ri, and in the output resistance R naught there is a current source which is depend on the input current, that is II. So AI is the gain, and there is a output current I naught which is input of the feedback network, and output is the IF which is output of the feedback amplifier. So first we find out the voltage gain. So we know I naught is equal to AII, because here basic amplifier is nothing but a current amplifier. So I naught is equal to AII. That means we know A is equal to output current by input current. So here I indicate from here that IS minus IF. So also we know from the feedback network, that is beta is equal to output. What is output? Output is the IF and input is the I naught. So we can write IF is equal to beta I naught. So we put IF in this equation, that is A IS minus beta I naught. And to simplify these equations, we write down AIS is equal to 1 plus beta A I naught. So feedback gain of the feedback amplifier. So sometimes it is called closed loop. Open loop gain means only A, which is for basic amplifier, and closed loop gain, which is AF, which is with feedback amplifier. So open loop amplifier and close open loop gain, it is called open loop gain, and close loop gain, this is called, that means open loop amplifier gain is A, and for closed loop amplifier closed loop gain is AF. So similarly we see AF is equal to I naught output by IS. Output is of the feedback amplifier I naught, and input of the feedback amplifier IS is equal to A by 1 plus A beta. So it is proof as a negative feedback because it is minimize the actual gain or decrease by the factor of 1 plus beta A. So now we find out the input impedance. So how do we find out input impedance? The notation is Z in for input impedance. So input impedance is the VI by IS. VI by IS, input voltage by input current. VI by IS. So VI by IS we can write again II plus IF. So we can write VI is equal to II into RI, because we know the input resistance is the RI. II plus beta I naught, because IF we know beta I naught. So is equal to II RI by II plus beta A II. So we can write Z in Ri by 1 plus beta A. So Ri is the input impedance of the basic amplifier, and R naught is the basic output impedance of the basic amplifier. So now we find out the input impedance of the feedback amplifier whole circuit and output impedance of the feedback amplifier. So we see here input impedance of the feedback amplifier is nothing but a Ri by 1 plus beta A. That means Ri by a factor, divided by a factor, that means it is decrease, reduce. So in case of feedback amplifier, the input impedance reduce than the basic amplifier. So similarly, in case of output impedance, apply a test voltage to the output. Z out means output impedance is equal to V naught by I naught. So applying test voltage, that is V naught by I naught, is equal to V naught is equal to I naught minus AII into R naught by I naught. Repeat, V naught is equal to I naught minus AII into R naught by I naught. If you simplify it, we see II plus beta I naught is equal to IS, where 0 II is equal to minus beta I naught. So we put it, repeat, II plus beta I naught is equal to IS, which is equal to 0. IS is equal to 0 when we find out the output impedance. So II is equal to minus beta I naught. So we can write Z out is equal to I naught plus A beta I naught into R naught by I naught. So if you simplify it, then we see Z out is equal to R naught into 1 plus A beta. That means R naught is multiplied with the factor 1 plus A beta. So output impedance is increased than the basic amplifier, because in case of basic amplifier, the output impedance is R naught. In case of feedback amplifier, output impedance is equal to R naught with multiply with the factor 1 plus A beta. So this is the output impedance for the current sampling and shunt mixing. So we see here that this topology is nothing but a negative feedback amplifier. Due to this A1 plus beta A, and the input impedance is the decrease and output impedance increase. So similarly, we can also find out the voltage gain and input impedance and output impedance of the current sampling series mixing. That means series topology. So here, this is the basic amplifier. This dotted line where Ri is the input impedance, R naught is the output impedance, and this dotted line is the feedback network. So in basic amplifier, the gain A is nothing but a I naught by Vi, and in case of feedback amplifier, beta gain is equal to output Vf by input I naught. So for the voltage gain, we can write I naught is equal to A Vi. Vi we can write Vs minus Vf, and Vf is equal to beta naught Vi. So from these equations, we can write A into Vs minus beta I naught is equal to I naught. So A Vs is equal to 1 plus beta A I naught. So we find out the feedback gain AF is equal to output I naught input Vs is equal to A by 1 plus beta. Again, this is indicate the negative feedback. So similarly, we can find out the input impedance Zin is equal to input Vs by Is. Vs is nothing but a Vi plus Vf by Is. So Vi plus Vf is beta I naught. So beta I naught is equal to Vi plus represent I naught. I naught is equal to A Vi. So beta into A Vi. So Zin is equal to Vi 1 plus beta A by Is, which is equal to Ri into I 1 plus beta A. That means increase increase the input impedance for this topology, because Ri multiply with the factor 1 plus beta A. Similarly, in case of output impedance, apply test voltage, that is V naught by I naught, where V naught is equal to I naught into R naught minus A Vi R naught by I naught. Similarly, Vi plus beta I naught is equal to Vs, which is 0. So we can write Vi is equal to minus beta I naught. 0 means we make it constant, or 0, we find out the output impedance. So it is 0. So beta is equal to minus Vi naught. So jet output is equal to I naught plus A beta I naught into R naught by I. So we can say jet out is equal to R naught 1 plus A beta. So in this case also increase. So current sampling series mixing topologies, we see the gain is negative feedback, and input impedance and output impedance both are increased than the basic amplifier. So this is about the current sampling. So up to now, if any queries, you can ask. Up to now, if any queries, next day we discuss about other topologies and any another parameters of the topologies. Okay, any queries up to now? Today we discuss about feedback topologies. First we discuss about the feedback amplifier, where we see feedback amplifier two types, positive and negative, where in case of negative feedback, where the gain of the basic amplifier is reduced, and whereas the positive feedback amplifier it is increase. But we use positive feedback amplifier with certain condition as a oscillator. We discuss about it further. Then we discuss about the block diagram of the feedback amplifier, and we classify the different type of topologies, four topologies, and then we discuss about the block diagram of the four topologies, which is where each topologies use consist with the different basic amplifier, that is current, voltage, transconductance and transresistance amplifier. And then we see in case of current sampling and shunt mixing, gain, voltage gain, input impedance and output impedance, where we see voltage gain is the negative feedback, and sampling is mixing, we see voltage gain is negative feedback, and input impedance and output impedance both are increase. So if any queries up to now, you can ask. So if not, then I stop here. If no queries, so stop here. Thank you all of you.